Today we are going to learn about understanding OAuth 2.0 for secure API access. This video will teach you the fundamentals of OAuth 2.0, its key components, authorization flow, and best practices for securing API endpoints. OAuth 2.0 is an open authorization framework that allows third-party services to exchange user information without exposing credentials. This protocol is vital in securing APIs, as it enables applications to access resources on behalf of a user by obtaining a token. OAuth 2.0 is widely adopted due to its flexibility and robust security measures, making it essential in today's web applications. In this video, we'll dive into how OAuth 2.0 works, its components, and how you can implement it to protect your API endpoints. The OAuth 2.0 protocol consists of several key components. Firstly, the resource owner, typically the user, who authorizes an application to access their data. The client is the application that requests this access. The authorization server is responsible for authenticating the user and issuing the access token, while the resource server hosts the user's data and verifies the token before granting access. Understanding how these components interact is critical to implementing OAuth 2.0 correctly. Each component plays a pivotal role in ensuring secure and safe data transactions across applications. The Authorization Code Grant is the most common OAuth 2.0 flow, especially suited for server-side web applications. It involves redirecting the user to an authorization server, where they log in and grant access. The server then redirects back to the application with an authorization code. The application exchanges this code for an access token. This flow provides a high level of security by keeping tokens out of the browser and enables the server to authenticate itself before exchanging the code. It's essential for scenarios where client credentials are confidential, such as server-side applications.
OAuth 2.0 offers several advantages over other authentication protocols. Unlike OAuth 1.0, it simplifies the communication process and enhances security by removing the need for complex signature processes. Compared to basic Auth, OAuth 2.0 provides token-based authentication, which is more secure and flexible. While OpenID Connect is often compared to OAuth 2.0, it is an identity layer built on top of OAuth 2.0, adding user authentication features. Selecting the right protocol depends on your specific security needs and application requirements. OAuth 2.0 is generally preferred for its balance of security and ease of implementation.
Implementing OAuth 2.0 in web applications begins with setting up an authorization server capable of authenticating users and issuing tokens. Next, you'll need to register your client application with the authorization server, specifying details like redirect URIs. Once registered, your application can redirect users to the authorization server to obtain access tokens. These tokens are then included in API requests to access protected resources. It's crucial to handle tokens securely, storing them in a secure manner and implementing token refresh mechanisms to maintain access without requiring re-authentication. While OAuth 2.0 provides a robust framework for authorization, common pitfalls can undermine its security. Ignoring token expiration is a prevalent mistake. Always ensure tokens are refreshed before they expire. Tokens should be stored securely to prevent unauthorized access. Misconfigured redirect URIs can be exploited for attacks. Ensure they are properly validated. Always verify token scopes to ensure the token grants only the necessary permissions. Understanding the different grant types is crucial. Selecting the wrong type can expose sensitive data. Being aware of these pitfalls is essential for secure OAuth 2.0 implementation. Securing OAuth 2.0 tokens is paramount to protecting user data. Always use HTTPS to encrypt data in transit. Regularly rotate tokens to minimize the risk of unauthorized access. Implement token scopes to limit token permissions to only what is necessary. Limiting the token lifetime reduces the window of opportunity for misuse. Additionally, monitoring token usage can help detect anomalies and unauthorized access attempts. By following these best practices, you can significantly enhance the security of your OAuth 2.0 implementation, ensuring that user data remains protected. OAuth 2.0 is widely used in various real-world applications. Social media platforms like Facebook and Twitter utilize OAuth 2.0 for third-party app integrations. Cloud services, such as AWS and Google Cloud, implement OAuth 2.0 to manage access to their APIs. In mobile apps, OAuth 2.0 ensures secure communication between the app and cloud services. Notable examples include Google APIs, which use OAuth 2.0 for user authentication and authorization, and the GitHub API, which allows developers to access repositories and user data securely. These case studies highlight the versatility and effectiveness of OAuth 2.0 in diverse applications. In conclusion, OAuth 2.0 is a powerful tool for securing API access, offering flexibility and robust security features. Understanding its key components and authorization flow is crucial for effective implementation. By following best practices and being aware of common pitfalls, you can enhance your application security and protect user data. We encourage you to adopt OAuth 2.0 in your applications and prioritize API security to build trust with your users. Thank you for joining us in exploring OAuth 2.0 and its essential role in modern web security.